And hello all, Mr. Callan back here with you. I'm here to help you with the assignment for Friday, May 8th, entitled Repeating Decimals, Day 2. If you're looking at your Google Classroom, might look a little similar to mine, maybe a little different. Steps here, read today's overview. That would be below. We'll talk about that in a second. Optional experimental live teaching session. That's going to be, again, 2 to 2:30 for math lab classes and 2:30 to 3 for normal hours 5 and 7 classes. Number 3, watch the video. That's what you're doing. And number 4, complete the assignment with the challenge, of course, always available. Now I'm going to remind you where we've been so you know where we're heading. So a reminder that once upon a time we learned how to convert terminating or stopping decimals into fractions or mixed numbers, 4/10, 35/100, etc. However, we then came across the problem, what happens if those decimals go on and on and on forever? Today, we're adding a new wrinkle. What happens if those decimals go on forever and they have whole numbers out in front? Consider that as we continue along. Here's today's overview for Friday, May 8th. I have started putting due dates on the assignments. I think that helps us better organize ourselves with Google Classroom. So the due date would be 5 school days from now. I know what that is, basically a week, so May 15th. But of course, you want to get this done as soon as possible. We'll go into the gradebook beforehand. Same learning objective, convert repeating decimals into equivalent fractions or mixed numbers. Today we're going to review what we've already talked about and use the same skills to convert repeating decimals into mixed numbers. Review videos, what you're watching now, practice and challenge, of course. Liked this quote, seemed appropriate for the time now. For everything you have missed, you've gained something else. I hope you guys have figured several things that you're gaining from this very difficult kind of situation we're all going through, but let's take the worst and make the best of it, shall we? All right, really pumped up about students' responses to the last day's assignments. How were all the problems similar? Several people kind of talked about directions, converting repeating decimals into equivalent fractions. Simplest form, all had repeating decimals. All used n as a variable. That's just something that I learned at one point in time. You really could use any variable you want, x, b, m. You could use a Greek variable, chi, delta, alpha, whatever. But we'll use n. Now, I like the next few. You had to either use 10 n's or 100 n's, and you had to subtract in all the problems. Those people are really getting towards the step-by-step instructions, so I love seeing those similarities. Meanwhile, all the answers had a denominator of 9 or 99. I noticed some people saw some patterns, but that's not always going to be the case. So be careful trying to find patterns and shortcuts. Let's learn the number sense and the algebra behind it. I can respect those of you who saw some patterns, but you better learn the algebra behind it because that will not always be an answer with a denominator of 9 or 99. Check out the challenges from the last assignment or today's assignment if you want to see that's the case. Moving into how they are different, several students, starting with the obvious that the numbers are different, they'll have different answers. Nice for the next few people that said, hey, some are in the tens place, some are in the hundreds. Next person, some problems have more than one place value that's being repeated. And the next person even put examples. Obviously hard to put the repeating sign in the computer code, but 0.53 repeated or 0.5 repeated. So people really starting to look at the slight but very important differences. Now, speaking of the number of place values being repeated, the next person, all different, because all the repeating decimals are different. Some of you have to use 100 n's instead of 10 n's. So again, seeing those important connections. And speaking of the 100 n's or the 10 n's, the next person put, sometimes you have to do 10 minus 1 or 10 n's minus 1 n. Sometimes you have to do 100 n's minus 1 n. And then the next person, some you have to divide by 9 and some by 99. So love it, getting into the step-by-step instructions. And I want to point out, this one, I just could not put enough good things here. You guys wrote so many good ways to give yourself step-by-step instructions. And I'm sorry I couldn't include all of them, but let's just pick out a few, okay? Because I was really pumped reading so many good stuff. Number 1, write n equals and then the decimal. Step 2, above the n equals, put a 10 n equals if there's only one number in the decimal, or you can put 100 n equals if there's 2 repeating decimal places. Step 3, next to the 100N or the 10N, you move the decimal place to the right however many times. So if it's 1 repeating decimal, they put an example of 3.3 repeated. If there's 2 repeating decimals, they put an example of 35.3535 repeated. Step 4, you line the problem up and subtract it. Step 5, 10Ns minus 1 Ns, 9 Ns, or 100Ns minus 1 N is 99 Ns. And on the other side, it's just one number, so they put their examples, leaving a 3 behind or leaving a 35 behind. Step 5, bring down the 9 Ns or the 99 Ns, whichever it is, and divide. Put it underneath the number on the right as well, so kind of being fair to both sides. Divide by 9 or divide by 99. And then you will have your answer. So I'm going to really use this person's instructions as I go through my own examples. Next person really liked it. Not only wrote step by step, but also had an example to explain the steps. So I'm going to encourage you, if you wish, press pause here and go ahead and read it through at your own pace. So I really want to give applause to this person as well as the person above. Step by step, this person even included examples, did their best with the messiness of the typing to even show at the bottom 9 Ns divided by 9, 2 divided by 9. The answer is 2/9. Sorry about that. Let's go to the next one. This kind of blew my mind because this person's almost psychic knowing where we're heading to today. Look at their example, 2.6 repeated. Aha! There's 2 holes in front of there. So if you wish, you can press pause right now and take a look at this person who's teaching 2 days ahead of what I'm going to teach today, which is pretty sweet. All right, take a second if you want to read through that. So, really impressed with that person. Again, if you wanted to press pause, rewind, do what you want. Plenty more good examples. I want to be clear to all those. I just didn't have enough space, nor do I have enough time to read through all of them, but really good stuff. The only way I could be more excited about this is if I had more people filling out those exit problems. I'm telling you folks, if you can find similarities, differences, and then a summary, like a step-by-step how-to any, you can learn better anything, science, language arts, a foreign language, anything. So keep up that good work. Let's go ahead now to today's assignment, convert repeating decimals number 2. Again, what I do right at the beginning is I look at the answers in red and I just kind of cover them up. I don't want to look at those answers right now, so I'm going to erase them, and you're welcome to do the same. One thing you will notice very faintly on all those problems, I've written the word optional, and in the top right-hand corner it says first page is optional. Do this if you want some extra practice. This stuff will, of course, be coming on a quiz, coming soon to theaters near you. But we're going to do problem 4 as kind of our example, and then your assignment will be 6 problems on the back, 8 for those looking for a challenge, and as always, don't just put in the minimum effort. Try the maximum effort. Even making mistakes, you can learn from it. If you want some extra problems, that's why I included that first page here. So here we go, folks. Let's take a look at number 4, where I'm going to do 2 different methods, and then in the end, you get to decide which one you like best. Now, frankly, I'm going to use the method that this person wrote about in their own example. I'm going to do that first. So the very first thing the person said is to write n equals, and if you want, you may write the 1 at this point. You guys are getting used to saying, all right, Mr. Callan, I don't need to write that. And here we have a value of 2.37 repeating. So I'm going to write a number of 3s and 7s and 3s and 7s. Now, what we learned from the other day is that here we're going to have to multiply not just by 10, but by 100. And why do we multiply by 100? Because we're going to have not 1, but 2 repeating decimals that we want to deal with. So if we were to multiply 100 n's, we'd get 100n. And if we're multiplying 2.37 by repeating by 100, it's going to move the decimal place 2 times. So that's going to give us 237 wholes. And then it still has 0.373737 and so on. Now let's go ahead and subtract and see why we did that. Does that help us out? Naturally, on the left, if you have 100 n's and you take away 1 n, you're going to have 99 n's. Now we have to be fair to the right side to keep the equation fair, balanced, and equal. So here we have 237, take away 2. Now that's interesting. 237 take away 2 is 235. But you will also notice that 3 take away 3 is 0, and 7 take away 7 is 0, and 3 take away 3 is 0, and 7 take away 7 is 0, and all those 3's and 7's cancel out to infinity, and we no longer have that messy, never-ending decimal place in all those portions. Hey guys, we're doing great. All we got to do now is say, look, I don't want 99 ends. I want to know what a single n is. So let's take 99 ends and 235, and let's split both of them into 99 parts. Now, of course, this will leave us with one n, which you guys are getting tired of writing by now. And look here. We have now figured out that 2 wholes and 37 repeating is the same as 235 99ths. Now, that's a good answer, but it's not a great answer. I think we can go a bit farther and say, how many wholes is that? And then how many parts is that? Naturally, it'll still be 99 parts, or 99 that's split into. But what happens if I divide 235 by 99? Well, I know 99 goes into 235 2 whole times. 2 99s is 198. And look what happens when I subtract them. Of course, I'm going to have to borrow, going to have to regroup. 15 take away 8, 2 take away 9. Going to have to borrow and regroup again. 12 take away 9. And ha ha ho ho. Suddenly we have 2 wholes and 37 99ths. So I'm going to write that as well at the top. And that is method 1, ladies and gents, which is pretty similar to what we've been doing for the last couple days. Now let's go into method number 2. And I really think this is going to be the fan favorite, because here's why. For method number 2, all we're going to do is pretend the wholes are not even there. Now the reason for that is we can set up the usual equation, just like yesterday's stuff, of having no wholes and 0.37 repeated. Naturally, we'll multiply everything by 100 because there's 2 repeating decimal places. 100 sets of n is 100 n's. 100 sets of 0.37 repeated move to the decimal place 2 times to give us 37 wholes, 0.373737. Notice that everything lines up quite nicely. So let's go ahead and be fair and subtract everything from both sides to keep a fair balanced equation. 100 n's minus a single n, 99 n's. 37.37 repeated minus 0.37 repeated. Well, look at there. Once again, all those 3's and 7's to infinity are gone. Now let's go ahead and solve by taking 99 n's and 37 and splitting both up into 99 parts. Naturally, that'll leave us with 37 99ths. But please don't tell me that 2 wholes and 37 99ths is the same as 37 over 99? How is that possible? There's no whole. Okay, you know what we can do? We're going to take the 2 wholes and we're just going to put it back in. Boom! 2 wholes and 37 99ths. So to review that second method, you essentially take the 2 wholes away, put it in your back pocket, act like it's not even there. Deal with the portions, the pieces. 0.37 repeated is the same as 37 over 99. And then take the 2 wholes out of your back pocket and put it back in. So 2.37 repeated is the same as saying 235 99ths. Or 2 wholes and 37 99ths. Now again, while both of those answers seem to be just fine, I'll be honest, I feel like one is the better way to write it, 2 wholes and 37 99ths. I don't think I'll take off points. Maybe I'll take off a half point if you were to leave it as 235 over 99. It's not wrong. It's just not the best way to write it. So folks, with that, I will let you go. I would encourage you to pick one method and go after it and use it. Now, if it helps, some of you need a challenge. Some of you should be able to do it with both methods. I would just always encourage you, in the end, if you accidentally leave out the whole, ask yourself, how can 2 wholes and a part be the same as 0 wholes and apart. Always make sure that your holes match up if these really are equivalent amounts of pizza or money or length or whatever. Now, as always, let me know if you need any help. Email or message me, and I will be there to help you. Thanks, folks. You have a great day.